Even the E matrix is not invertible, so this system is degenerative. It's singular. It's called generalized system.
Yeah, for invertible, the equivalent.
Yeah, it's just a traditional one. So we live with those choices. There's a reason to think in this way, and we can talk more later. But even with E is not invertible, we can still do stabilization of the dynamic system. So basically, the simulation she's trying to show is it works. Next.
Next. Second part is
We have seen this one. What's new?
what we want to achieve next. And this system, I give it a name, master-slave system. I don't know whether it
Slave,
is.
how it's being used, sorry. I want to call it a nested fractional order system.
The system 1, the order alpha is time variant. And for the system 2, the output of system 1 is the parameter of the order of the system 2. Yes.
So the order is time varying, and that time varying can be an output of another dynamic system, which is true. Imagine that you just cook the fraction of capacitor, whether this order of the capacitor will change, so, which is true. How to harness that property. So I believe in the future, in the nano manufacturing and the nano world, there is a place for this kind of thing.
Here we want to design the U1 and U2. Finally, stabilize the whole system. And before this work, I want to do some simple. First step for the two system alpha is also time invariant. Yes, and the system 1's output y1t is the input of the system 2. And I think this system is easier about that.
Thing is being done.
It will. I think it will be done in about 2 weeks. Yes.
Okay, let's see what's new.
And the second step, for the second step, different from this is the alpha 1
Is a constant.
is constant, and this is the similar with the final we want to do. After the two step, I think I can do this system stabilize. For this system, I mainly do here E. E is y2 dt minus y2 t, and we want to obtain the response of E, and I like it has this next step to 0.
Oh, okay. Or some asymptotic stability. Decaying to 0.
And until now, for the fractional dynamic order system, this is the system 2. For the system 2, we have some results. The stability condition we have found. This is her.
I'm not convinced. Okay. Is this for all t? You need to check this inequality for every t. Is that true?
I haven't do the simulation, but just give this.
I'm suspicious. For constant alpha, it's true. I know that. But time varying one, I'm not convinced.
Part of the problem, sine and cosine are bounded. Are bounded functions, so it is easy to check this condition.
I don't know. Until I see a solid argument about it. But I want to give you a pre-warning about a classical result about this one. So for example, this is 1, so x dot. There's no this, no this, no this. So you only have A is time variant t. So we know that the eigenvalue of the A is on the left half plane. The system is stable, asymptotically stable.
Yes.
But if this is time varying, for every t, this is true, all the eigenvalues on the left-hand side, is the system stable? The answer is no, surprisingly. Surprising. It's related to the rate of the change of the A of t also. And also I trust the rate of the change of alpha t could be contributing factor of the stability. Okay?
I see your mean.
So that's why I suspect this. There's no alpha dot in it.
I will do the simulation later, and I will.
Okay. Simulation you cannot use to prove it. Just give you inspiration. Okay, next.
For this system, we want to design the fractional dynamic output feedback controller like this, and this is the little work. And after this, for the fractional fuzzy dynamic order system like this, here alpha t is the fuzzy system here, so we call it fuzzy dynamic order. For this system, we want to design the fractional fuzzy dynamic order output feedback controller. And I hope that it will work well.
That's beyond my imagination. I'm not good at fuzzy. So.
Last is conclusion. And for normal fractional system, we build a stability condition and design the output feedback controller. And second, for the fuzzy fractional order system, we translate to an equivalent answer system and also design the controller. And three, for the singular fractional order system, we build a stability condition and design the state feedback controller. And four is the for the fractional dynamic order, we want to analyze the stability and build the condition. Also want to design output feedback controller such that overall system is a system particularly stable. Last, for the fractional fuzzy order system, want to design the output feedback controller. Hope that the system is stable.
Okay, looks like a very complicated. It must do even with good control training. But let's see what interesting results you can have.
This is the acknowledgement. Dr. Chen helped me give me many ideas. Thank you very much. And Mr. Hong Guangsun gave some many good suggestions. And other CSOS members gave me many